It shows you exactly how a star is formed. Nothing else can be so pretty. A cluster of vapour, the cream of the Milky Way, a sort of celestial cheese, churned into light.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Oh yeah, baby Disraeli. Oh, Matt, we got that spot on. And big shout out to the person who still hates that jingle. We're sorry, but we're not going to be bullied into changing the show, yeah? We do this for us. And if anyone else actually, we don't do it for us, do we, Matt? We do it for infamy. Somebody's got it infamy. Who made that joke? Was that Monty Python?
Infamy. It's a Carry On Cleopatra.
My lord. So, Matt, Benjamin Disraeli, 1847. What do you think?
Well, amazing. Yeah, he was the British Prime Minister for a couple of times, inventor of the modern Tory party. So not all Tories are bad. Not all Tories
are bad. Well, just most of them today. I mean, Matt, you told me that he was regarded by some as our greatest Prime Minister. Is that true?
Yeah. Well, yes, he was a sort of polymath kind of Prime Minister. I mean, you got your Churchills as well, remember?
You got your Churchills.
But a lot of these people, when judged by today's standards, they might not sort of hold up very well. Bizarrely, he had controversial wars in Afghanistan. How little changes.
Yeah, there was a few controversial wars from a lot of our prime ministers. But Matt, I tell you what, on a lighter note, we've got Happy Birthday, haven't we?
We do. Happy birthday to the ancient Persian astronomer from the 15th century, Olug Beg.
I like that name.
Yeah, the great ruler. That's what his name translates as.
His
real name is Mirza Mohammed Charagay bin Shahrukh.
So we're talking 15th century, and as a child, he wandered through the substantial part of the Middle East and India as his grandfather expanded his conquests.
His family are very, very influential in that part of the world. But the reason why we're happy birthday is because he built this absolutely enormous observatory called the Olug Beg Observatory in Samarkand, which is now called Uzbekistan. In 1424, one of the finest observatories in the Islamic world.
Tell me it's still there, Matt.
It is still there. You can go and visit it. I mean, it's nowhere near as amazing as it was when it was being built.
Well, I love that it's still there. I think we should go on a tour.
You'd be impressed with his hugely long sextant that he used to create.
Come again?
That he used to create one of the greatest star catalogues of his time.
Whoa.
Yeah, and we talked about the sidereal year a few podcasts ago.
I do.
Yes, he measured that to an accuracy of within 58 seconds of the actual number, only to be improved by Copernicus many Matt, years later.
Talking of numbers, I heard he had 1 or 2 wives.
13 to be precise.
Oh, lucky 13. My lord, 13 wives.
Mm-hmm. He's got a crater named after him on the moon and an asteroid.
Come on.
And he's one of those people that's had his face reconstructed by an anthropologist because his remains were found by Soviet archaeologists in 1941.
Do you think anyone's going to reconstruct my face after I'm dead?
Well, what you could do is get it scanned in now so no one has to kind of go through that rigmarole.
Won't be a rigmarole, Matt. They'll be like, oh my God, who was this legend that lies before us?
Not only is it Olug Beg's birthday today, it's also on this day, the 22nd of March. Back in 1981, we had Soyuz 39 with Jagdadamidin Garagdakar.
You've pronounced that before.
Yes, who is the first person from Mongolia to fly to space.
Wow.
Yes, and went on board Salyut 6. And he then later became the Mongolian defence minister. But this is my favourite bit. He now funds the development of a sport called bandy, which is a type of ice hockey in Mongolia.
Is there much ice in Mongolia?
Yeah,
I guess there is.
I don't know a great deal about Mongolia.
I know there's mountains. and lots of planes.
I know what the Mongols look like.
Have you heard about their throat singing?
Yeah, oh yes.
It's really something.
It's one of the most amazing things I've ever heard on the radio is a sort of 13-year-old girl doing Mongolian throat singing. It's so scary.
Our listeners love a cliffhanger, Matt, and if there's anything that they're going to tune back in for, it's us maybe starting next week's show with some Mongolian throat singing.
Absolutely.
Well, you heard it here first. Tune in next week. Now, what's going on with the equinox?
Well, we've just passed the vernal equinox. And I know it's one of your favourites. So the equinox meaning equal night. In other words, 12 hours of sunshine, 12 hours of night. You could set
your watch by it.
The equal times. Yeah. What day was your birthday, Jamie?
It was the 19th of March, which was Tuesday.
So sometimes your birthday is the start of spring. Sometimes it isn't. Well, it wasn't this year. I mean, it was the 20th. But, and very rarely it's on the 21st. But I don't think that's going to happen again in our lifetime, by the way.
Well, Matt, you know why, don't you? Because when I was born, all the flowers suddenly bloomed.
Is that
Sweet
why
scent was in the air.
Oh, that's beautiful.
So there we go.
I read a little article about what other bodies in the solar system have spring.
Here we go. Hit me.
So Mercury and Jupiter don't, because they don't have any tilt. Venus, despite its tilt, is just hell on Earth all year round, so there's no real seasons there. Saturn, though, really does have quite a seasonal time. So, yes, when it's spring on Saturn, apparently the atmosphere is very blue, clear blue. And as it gets towards summer, it goes more hazy and more hazy gold of summer.
So so spring is a better time to see the rings, I assume?
I don't think spring affects the rings.
No?
Remember, we're talking about the weather on the actual planet itself.
Oh.
It certainly affects how we see the rings from Earth, of course.
Sometimes, that's what I meant, blood.
Sometimes when you look at Saturn, you can't really see the rings because they're completely side on, which is interesting.
Side on.
So one of the dreadful things that happened last week, amongst other lots of dreadful things that happened during the week, was this absolutely terrible Mozambique flood.
Yeah, awful.
Malawi, Zimbabwe, possibly the worst storm to ever hit the southern hemisphere, which is pretty incredible, isn't it? So it's Copernicus Sentinel-1 satellite have been helping to map the flooded areas and help the relief efforts. So, yes, Sentinel-1 was built mostly in Italy and is part of the European Commission partnership with the European Space Agency. So if anyone moans about why we spend money on space, it's things like this where it really, really comes to into its own, doesn't it? So Sentinel-1 is able to see through the clouds because it's got radar. It can see through the clouds and the rain so that you can actually see where all the flooding's happened. Of course, it's taken pictures of the area before, so you know how the whole area's changed, so you can see what the devastation is. So
how it was. And actually, Matt, I was today Googling about how satellites help poverty, because we touched upon it finding forced labour camps. Well, actually, it's also amazing at tracking vegetation and disease in crops, so it can help farming. But this is amazing too. I mean, obviously it's devastating flood, but the fact that we can use this technology in these awful situations is incredible.
For me, it's like global warming. We may not have even noticed it if it wasn't for our satellites. But on a cheery note, did you see the pictures of California goes into this crazy blooming of these orange flowers all over the place, and it looks very, very beautiful on the ground. But yeah, there's some pictures of it from space now, where the sort of green, these green mountainous hills, I guess where Busey lives, they all go orange. It looks absolutely amazing.
Up at Lake Arrowhead. We'll have to ask him. Can we get a picture up on the Instagram page, please?
Absolutely.
I'll tell you, Matt, what we can't go by without mentioning. Has everyone charged their glasses? It's SpaceX.
Mr. Musk.
This is the Starship. So our beautiful, shiny Starship. It was meant to be tested today. We don't know if that's happened. And that wasn't actually a launch. It was more of a hover, according to Elon.
Yeah, I mean, I don't think that even if you were watching that video, you'd actually be able to see it hover. But what I'm really trying to get my head around what they're actually testing? Because it's like, because I could understand the hoppers before, because that was testing all that, the ability to use the retro rockets and all on the software. But surely that software is exactly the same.
You would have thought so. So this is one Raptor engine instead of the what will be 3. Am I right?
Well, it's 3 for the suborbital flights apparently, but it's going to be a hell of a lot more for the actual.
Well, yeah, like
Starship.
20 odd, isn't it?
So the first stage will have 31 Raptor engines.
Jeez.
So that's the first stage is going to, of course, be called Super Heavy.
Yeah, because some of the engines are there just in case of failure of the others.
So actually, this is the second stage Starship, which is going to have 7 Raptor engines on it, which will sit on top of the Super Heavy, which will take
can't
it
stop
into...
looking at this Starship. It's so beautiful.
Well, it's so ridiculous. It just doesn't look real, does it?
No.
It's really weird.
It's just like everything that is great from SpaceX. It just seems like it's animated.
Yeah, well, it looks like a sort of model. It looks like a model rocket that they're going to stick a Raptor engine on the bottom and then sort of mess around with it for a bit. I genuinely don't know what's being tested, but Elon Musk really did go on Twitter and was just spewing out facts all over the place.
He was being pretty vague, wasn't he? Yeah.
So there was things like it's going to have hexagonal tiles on the windward side, and it's going to be using transpiration cooling. So transpiration cooling is a bit like human sweat, I suppose, but you use cold liquid to go through the shell of the structure to absorb some of the heat.
Right.
Oh, sorry, the super heavy booster part of it will just be stainless steel because it only goes Mach 8 or 9 and it doesn't even need to be painted. Where they're doing this in Boca Chica, they applied to make sure that the roads were all cordoned off and everyone was out of the way. So,
where is Boca Chica, Matt?
Texas.
Ah, it's in Texas.
Yes. So it's actually Boca Chica Village. See, that's been confusing me for a long time. It used to be Kennedy Shores or Coppernick Shores.
So the village were emailed and told that these tests were going on and that there would be some road closures.
SpaceX have been having a pretty good time, I have to say. SpaceX seem to be really getting back into their groove again.
They really are.
I tell you who isn't.
Go on.
Boeing.
Oh, what's happening now?
I mean, they really are having bad times.
Bit of a mare.
Well, they are, aren't they? So it looks like this first launch of the Boeing Starliner is slipped back to August. So they're miles behind SpaceX now, which will probably mean we won't see a crewed flight at the very earliest until November. So yes, that's looking pretty bad. That's not been confirmed. That was coming through the wires. I saw that in Reuters, I think.
But what about SLS? What's happening there?
Well, SLS, of course, that's hideously behind schedule. We've had all that news about, we can just use other rockets, and so if they slip behind schedule. And then suddenly last week, after that announcement by Jim Bridenstine, they were going, we'll work on the schedule. I'm sure we can pick up pace again. It's just like, well, why weren't you doing that anyway? It's just a bit of a night.
Exactly.
So
is that what had to be publicly said?
Yeah,
to make stuff happen.
Yeah, so Boeing, not so great there, and of course their 737 MAX passenger jet is really that's a bad scene, that one. 2 crashes and it really does look like it's some kind of fault with the aircraft that's been known about and kind of shuffled away.
Yeah.
So that's not great.
That is a bad time. But you know what? I think they're going to pull it round. I'm sending good vibes to Boeing.
I tell you, I saw a really interesting paper from researchers from Berlin and Moscow using the ISS toilet door as a place to test this new surface coating called AGXX, which one of the researchers, Elizabeth Groman, described as exploding the bacteria on contact. So it's a metal that consists of thin layers of silver and a metal called ruthenium. And it's treated with ascorbic acid or vitamin C, as you know it.
Wow.
Yeah, so this metal, because bacteria, not only are they getting a little bit immune to antibiotics, they're also getting immune to silver, because you know that silver's a really, really good antibacterial metal. But the reason why they've been doing it on the ISS is because space missions are plagued by this kind of bacterial biofilms that start coating all the surfaces and destroying all the equipment, which of course is bad news for the astronauts, because there's a risk, of course, of a terrible infection from one of these things. When they sort of did these kind of tests on Mir, for example, they found 234 bacterial and fungal species.
That's insane.
Well,
I didn't realise that was such an issue up there.
Yeah, well, the viruses are enhanced by space radiation and the way that the radiation affects their gene expression and stuff like this. So they become more virulent. And of course, it's harder for the astronauts to actually clean up because they can't use fluids to sort of wipe down and sprays like you do in a hotel. So yeah, it's pretty grim, isn't it? But apparently this AGXX stuff was really, really good. What's really weird about it is that the actual substance, this kind of metal, has a self-regenerating ability.
Can we get some to clean our microphones?
Oh my God! Exactly. Well, maybe microphones should be made of AGXX. That sounds like exactly.
Well, you heard it here first.
Yeah, microphone
Matt,
grills.
we need to take this out the podcast immediately and patent that.
We probably do, actually. I'm writing to Shaw tonight.
So, if this was left in, you know that somebody's already thought of this. One day we'll be millionaires.
One day we'll be millionaires, Jamie. Well, we're almost millionaires thanks to the generous support of our Patreons.
Well, I wish that was true, but you know what, Matt?
Mm-hmm.
I might not be a millionaire in the financial sense, but with our Patreons, I feel like we've got $1 million of love in the bank.
No way. I think that was the most beautiful thing you've ever said.
I'll tell you what else is beautiful.
Mm-hmm.
Can we talk about Bennu, please?
Do you know, this is the most overshadowed space mission ever.
You love this, don't you?
Well, I feel sorry for the OSIRIS-REx team because, of course, they were completely overshadowed by Chang'e 4 and all the things that happens with SpaceX and all the other things that were and let alone Ultima Thule all happening at the same time.
Yeah.
But OSIRIS-REx managed to get into orbit around the smallest body ever orbited around about the same time, right at the end of last year. So yes, it's been so for 3 months it's been orbiting Bennu. It's nowhere near what they thought it was going to be, and I love some of the quotes from some of these scientists.
Who's up first? Laurie Glaze.
Laurie Glaze.
Another great name. Acting Director of the Planetary Science Division at NASA.
Yeah, and she said the first 3 months of OSIRIS-REx up close investigation of Bennu have reminded us what discovery is all about. Surprises, quick thinking, and flexibility. We study asteroids like Bennu to learn about the origin of the solar system.
Now we're talking. Can I give you a quote from Dante Loretta?
Which is another great name, isn't it?
OSIRIS-REx principal investigator at the University of Arizona in Tucson. Do you know what, Matt? I've stayed in Tucson, Arizona, when I went on my road trip there.
Nice.
And I stayed in a motel, and outside of the tiny motel was like a 50-foot red chili. Just like a model of it.
Oh, that's lovely. Now everyone from Tucson will know where that is now.
They'll know where that is. Hello to you. I had a wonderful stay there. It cost me about $12. And the lady behind the reception desk made me some warm cookies. I mean, what more do you want for $12?
Do you know what? You've told your warm cookie story before.
I keep getting warm cookies.
Do you?
Yeah, because it happened to me in Alaska, which is my last story.
Oh, was it?
But this was another one. I guess people feel they need to feed me. I don't know why.
Do you go dressed as the Cookie Monster?
We digress. That's my problem. That's my problem.
Yeah, so
back to
the quote.
So
Dante Loretta say?
Dante Loretta said, The discovery of plumes is one of the biggest surprises of my scientific career.
These plumes of small sort of rocky particles all coming off the asteroid. But I think the big surprise is that the density of boulders is much more rugged than they were anticipating. So one of the problems is they've got to land touch and go, or tag as it's called, and this tag mission has had to be adjusted to a new mission called Bullseye Tag, where they've got to get it even more precise. And so Rich Burns, the project manager of OSIRIS-REx at NASA's Goddard Space Flight Center, said, "Bennu has issued us a challenge to deal with its rugged terrain, and we are confident that OSIRIS-REx is up to the task."
Wow, you have been banging out the quotes.
Yeah, so spacecraft will return a sample to Earth in 2023, and I really can't wait for that one. But here's my exciting one. The team has directly observed a change in the spin rate of Bennu as a result of what is known as the Yarkosvky, O'Keefe, Radzivsky Paddock, or YORP effect. So do you know what's...
That is a mouthful.
Yeah, so do you want to know what my space word of the week is going to be?
Let me guess. Does it have anything to do with YORP?
It has a little bit to do with YORP. It's the Yarkosvky effect.
Here we go.
Yarkosvky effect. Oh yeah, baby, Yarkosvky effect.
You know we're going to get double the complaints.
So it's a force that acts on rotating bodies, especially things like asteroids. That's kind of what gets affected by the most. But it's caused by anisotropic, and we talk about anisotropic things all the time. That the cosmic microwave background is an anisotropic map. So a kind of different properties in different directions. So I'll kind of give you one component of the Yarkosvky effect, which is the diurnal effect, or really you could just call it the daily effect. So something that happens daily in terms of if you consider like a spin a day in a asteroid's life, in the same way one spin is a day in Earth's life. So this spinning asteroid gets heated. Obviously, one side gets heated by the sun while the other one's in darkness. And just like the Earth, but the surface that's facing the sun gets really, really hot. So it's absorbing all these photons of energy, but it doesn't emit them straight away. And then by the time that the asteroids moved from that position where it was getting heated up, by about 2 p.m. in that position, it starts to radiate those photons off. So the warmest point of an asteroid is actually not the bit that's facing the sun. It's started rotating away. Now those photons are coming off and acting, I suppose, like a sort of little mini space thruster.
Wow.
But of course, it's absolutely tiny, so it's almost negligible. But we're talking about objects that are trying to stay in orbit for billions of years. So if you can imagine that you've got two results from the Yarkosvky effect, from this diurnal effect, and that's if it's a prograde rotator, which means just like the Earth, it's spinning so that there's a force in the direction of the motion of the orbit.
Makes sense.
So yes, as it's going round, it's spinning anti-clockwise as it's going round anti-clockwise. So if it's all spinning at the same kind of if it's prograde, where most of the objects in the solar system are, but if it's retrograde, then the photons will go in the other direction. So obviously in prograde ones, they will speed up slightly, and so their orbits will get bigger. So it will spiral away from the sun. But if it's in a retrograde rotation, it will actually start to slow down and therefore spiral towards the sun, which is one of the reasons why asteroids don't just stay in the asteroid belt, is because of this effect. There are seasonal effects as well over longer times. But there's a really interesting connection here. So Yarkosvky was a Polish engineer, and basically he just noticed this effect and wrote about it in a magazine or a little pamphlet, and it was noticed by an Estonian astronomer, a guy called Ernst J. Opik.
Right.
And he read Yarkosvky's pamphlet in 1909. And then decades later, while talking to someone else, he recalled the pamphlet just from memory. He didn't have it, and mentioned this Yarkosvky effect, and kind of basically rescued it from obscurity. And then it started to sort of really gain momentum, and people started talking about it. Now, Ernst J. Opik's grandson is Lempit Opik, who you know as the boyfriend of one of the cheeky girls.
What?
and the Lib Dem MP. He actually took asteroid strikes pretty seriously, and he's also a regular visitor down at the BIS. So I have actually met him.
Is he still with the cheeky girl?
No, he isn't.
That's what the question on everyone's.
No, well, he left the weather girl for the cheeky girl. It's always quite an intriguing character.
What a player.
Yes.
Well, I'd like to meet him.
So we mentioned the Yarkosvky-O'Keefe-Radzivskill-Paddock effect, or YORP.
I mean, it's what everyone was waiting for.
So this one was a term coined by David P. Rubinkam to honour 4 important contributors to the sort of overall effect of lots of different things happening to these asteroids and stuff in the solar system. So obviously Yarkosvky, as we've just mentioned above. Then you've got Vladimir Radzivskill, who applied the idea based on albedo. So this is how dull or how shiny an object is. So obviously, if it's very, very shiny, it's reflecting lots of those. So if you have an object that's half dark, half white, like a sort of weird domino, for example, it would start spinning because obviously the dark side wouldn't be radiating out the photons; it'd just be absorbing them, while the light side would be bouncing them off, and that would start to cause it to spin, for example.
Wow!
And then Stephen Paddock realised that the shape was even more effective as a means of altering the body's spin rate by the way that the photons were being irradiated.
Matt, do you remember the chocolates vice versas?
Yeah, well, vice versas would be all over the shop.
The milk chocolate on the outside and white chocolate on the inside, or were they mixed up?
No, there was some of those like Maltesers that were sort of half white, half dark,
half and half,
halfy half.
Oh, really?
Yeah.
I don't remember them.
Well, they would be the ultimate for the Paddock for the Radzivskill effect, wouldn't they?
Well, if anyone can find any, and could Maltesers send us a batch?
Good
Just
call.
A couple of cases.
Oh, good call.
Just for science.
So Stephen Paddock and John O'Keefe then realised that this YORP effect could lead to rotational bursting. So they would start rotating so fast that the whole thing would fall apart, which would leave them reduced to dust.
Oh, that doesn't sound good.
Yeah, so the surface of an asteroid is acting in 3 significant ways. Radiation from the sun is absorbed and re-emitted as photons. Photons diffusely reflected by the surface of a body, and the body's internal energy that's emitted as thermal radiation. So, of course, obviously that you might have radioactive elements or just retained heat from the beginning of the solar system that's radiating out in different ways and forcing this body to start spinning. So it's a really important effect, but tiny.
I enjoyed that way more than I thought I would have done when you first started.
What, the Yarkosvky effect?
So I'd like to thank you.
You think to yourself, well, you know what would make an asteroid start making its journey into the inner solar system? And it makes you realise just how hard it is to protect the planet from all this, because imagine how complicated this has now become. You had things just
it's just insane.
That you had these things just sitting in orbit, but they're not. Now these tiny little forces can dislodge them, and they start making their way into the solar system, and then suddenly they cross the path of Earth and wipe out all the dinosaurs. It's not like a sort of it's not a trivial thing.
Well, Matt, I think it's a beautiful thing. And I tell you what, staying on eternal energy, we've got an interview with David Warmflash.
David Warmflash, yes. David Warmflash, who has written a book called, well, it's not even out yet. It will be out in the UK. Well, out in America on May the 7th. And in the UK, it looks like May the 7th as well, that you can order it from Amazon. So I'm going with that.
That's how current we are.
Yeah.
This isn't even out.
It seems to be a complete, right from the beginning, right to the end, everything that he can think of about the moon. And it's really fascinating. So he took the time out, literally running around from a cafe and driving and picking his kids up to talk to me about some of the things. And some of them, he made it quite UK centric, which is quite cool, because I noticed there was quite a few. There was chapters on the BIS, and there was even a mention of Birmingham. So I couldn't let that go, Jamie. So
definitely not. Did you say it's God's country?
I did.
Yeah.
And for those who don't realise that, of course, Lord of the Rings is very much about Birmingham being Mordor and Worcestershire and Gloucestershire and all those places being the shires.
Also don't know, Matt was born in Birmingham, hence his pride.
And for those who don't know, Birmingham was also the centre of the start of the modern world, where the industrial revolution took place.
You haven't mentioned Shakespeare yet.
Oh, and of course, it's where Shakespeare's from. So anyway, so yes, Dr. David Warmflash, and you've got to admit that's a particularly great name.
Dr. Warmflash.
Yeah.
Well, thank you, Doctor. Not only have you got an incredible name, the book is going to blow people's minds.
Yeah, I really wanted to get him back on, actually, because it's a bit of a noisy interview. So there's going to be there's bits where I think that there's a few cutouts. So I apologise for that. But he's a prolific science writer, and I'd love to get him on. So with no further ado, shall we play this one?
Let's roll it.
Écoutez.
The Interplanetary Podcast is alive!
I'm joined by David Warmflash, Dr. David Warmflash, who is an astrobiologist and one of the first, or not the first, if I'm not mistaken, postdoctoral astrobiologists at NASA who's worked with David McKay. Is that correct, David?
That's right. The late David McKay was a mentor of mine for the astrobiology program, and he goes way back to the early Apollo program when he was helping train astronauts for doing geology on the moon. But later he helped found the NASA Astrobiology Institute, and he's the famous investigator who found what appear to be fossils in a meteorite that's from Mars called ALH 84001 that was found in Antarctica during the 1980s.
We have actually talked about that on the show before. It's it's an incredible find that didn't quite pan out, did it?
He's a good example of another. Sadly, he died in 2013. He's a good example of somebody who's a moon person and a Mars person. There are a lot of those.
Yeah, one of the reasons why that we're talking is that you've got a book called Moon: An Illustrated History that takes us from its formation right to the current day through culture and the space race and the future of things like the lunar village. So,
but I'm sure that your listeners are able to read and understand American English, or they can use a translation dictionary.
Yeah, it's
certain U's missing from certain words, like color spelled without the U, and so forth, and maths spelled without the S.
Oh, the worst. As long as you don't say Legos, then we're all right, I think.
Right. Okay.
So actually, yes, take us from the very beginning, because from what I understand, there's a little bit of controversy even about the formation of the moon itself.
Oh, a lot of controversy about the formation of the moon. The ideas about formation of the moon go back to the ancient Greeks. They go back to Anaxagoras of the 5th century BC, who is the first person we know about to state emphatically that the moon is not a god, that the moon and sun are not gods, that the sun is a hot rock, then it releases light that's reflected from the moon that's just a rock. And Anaxagoras thought that the moon had been flung from the earth. And for thousands of years after that, we don't have too many records of people talking about the origin of the moon. But in the 19th century, when the discussion of the origins of the moon starts to sound more what we'd call scientific, then there's a hypothesis that came out during the late 1870s involving a researcher from the UK, George Darwin, son of Charles Darwin, who had an idea that the moon formed from Earth's mantle, and somehow Earth was spinning way faster than it was spinning now, kind of similar to what Anaxagoras was saying. And it was flung up, and as a result of being flung up, it left the Pacific Basin. And based on Darwin's calculations of the secular acceleration of the moon causing it to move outward from the Earth, he extrapolated backwards with another researcher and came up with a figure of something like 54 million or 55 million years that he thought had passed since the moon had been flung from what then became the Pacific Basin. Of course, in those days, there was no theory of continental drift, and the idea was that the shapes of the continents must have looked the same way that they look today. So that, of course, we know that that's not true today. But he was one of the originators of lunar origins hypotheses. Another one that was happening around the time was Edward Roche, who had an idea that the moon had simply formed in orbit around Earth, that the moon and Earth had coalesced together. So that was put up against the Darwin hypothesis about the moon actually coming from the Earth, which is called the fission hypothesis, that the two worlds fissioned. Then later in the early 20th century, there's an idea that the moon had been captured by Earth's gravity, but it had come from the outside. And then in the late 20th century, in the 1970s, there was a giant impact hypothesis that is the most widely accepted hypothesis now, but it's not the only hypothesis. There are some problems with it that agrees with a lot of the data that come from Apollo in terms of isotopes, that there's a similarity in isotopes that match between Earth and the moon, and yet there are differences, and that the moon during Apollo, based on the initial analysis of those samples that were brought back by astronauts, appeared to lack volatiles, such as water. And that, putting those two things together, the fact that the moon seemed to have a very low iron content. The only thing that seemed to work was the giant impact hypothesis. But the moon actually does not lack water, even deep inside the rocks. And because of that, there's those who follow the giant impact hypothesis are tweaking it constantly to make it work. And it may turn out not to work. That is the Hartman and Davis hypothesis. William Hartman and Donald Davis, 1975. And the newest hypothesis is the multiple small impact hypothesis, which comes out of the Weizmann Institute in Israel from Oded Aronson and colleagues. And it may possibly take the best of everything to be consistent with all the observations. Now, one key observation was samples that were picked up by astronauts of Apollo 15 and Apollo 17. And if you recall, Apollo 17 was the only mission that had a trained geologist on it, Harrison Jack Schmitt. And there was pyroclastic ash that was found on the moon that pretty recently thrown out of possibly some volcanic activity, but from deep within the crust. And there was a mineral in there called olivine. And at the time, in the 1970s, they didn't have the technology to look at it that carefully. But then in the early 2000s, around 2008, I think, because of the technology, they were able to see that embedded within the olivine crystals in that pyroclastic ash was water molecules. And there's no way that that should be in there if the moon had been heated as much as it would have been heated if a Mars-sized object had crashed into Earth, basically melting both worlds to cause the formation of the moon. It's really hard to show. And so the giant impact hypothesis actually has some problems now because of these results. So amazingly, lunar materials that were brought to the moon in the early 1970s are answering some major questions very recently. In fact, there's some pristine lunar samples that are just getting opened right now. The technology is ready now to start looking at things pristine. And they did that on purpose. They sealed them up.
I've been reading papers about some of those Apollo 17 rocks that actually came from Earth.
Which confirms what we've been thinking in terms of all the impact that's going on. And the one thing that's the moon has really taught us since the days of Apollo is the inner worlds of the solar system getting impacted constantly during the first few 100 million years of the solar system. And beyond that, really the first billion years or so, which has taught us a lot about the origins of everything we know on Earth and the origins of life and all that.
We've dealt with, or we've actually opened up a little bit of a mystery for the formation of the Earth. So what I found intriguing about the book is that we seem to have a few chapters that are very UK orientated. Can you tell us a little bit about them?
Yeah, sure. Yeah, there was a lot. I mentioned George Darwin. Of course, it's the same way that these early modern period, this is in the centuries following Isaac Newton, who was, of course, connected with the moon because the question that he asked himself, not did an apple fall on my head, that's probably urban myth, but he did ask himself the question, what's causing the moon to move? Why is it orbiting Earth? And that was one of the thoughts that led to gravitational theory, Newtonian gravitational theory. And that would not have happened with Sir Edmund Halley, who paid for the publication of Newton's Principia. So the two of them working together, and Edmund Halley himself was involved in the studies of the secular acceleration of the Earth. That has to do with the tidal forces that's causing the moon, its orbital velocity to increase, causing it to move further away from Earth, something that's more recently been measured by taking laser beams and bouncing them off reflectors that the Apollo astronauts placed on the moon. They've also got Sir Arthur Eddington is involved in the story of the moon. He's early 20th century. He was involved with Albert Einstein. The moon was vital to proving general relativity. What happened was that general relativity, unlike Newtonian gravitation, thinks of gravity as a bending force as opposed to a pulling force. To prove his theory, Einstein knew he had to show that light is bent by gravity. Space is bent by gravity, so light should be moved closer to a gravitational source than where you would expect it. And the highest gravity that we have is the sun in our region. And so the idea was if you could show that a star its position would look closer to the sun when it's almost in the direct line of sight of the sun than it would at the opposite end when the sun is on the other side of the sky, that would prove generally. But you can't just look at the sun, at least in those days you couldn't. So it had to be done during a solar eclipse, namely when the moon is blocking the sun. So it's utilization of the moon to prove general relativity. And there's a nice story associated with that. First, in 1914, Einstein recruited a German astronomer to help him with that. And it turned out the timing was kind of bad. There was supposed to be a solar eclipse, and it was supposed to be happening in the Crimea and in Ukraine and that area of the world. So the German researcher was sent there, and also an American researcher, William Campbell, went to near Kiev. And the summer of 1914, not much going on then.
Yeah.
So as he's sort of traveling eastward, Germany and Russia get into a thing called World War I. So he's there with telescopic astronomical equipment, big spy equipment. And he's arrested by the Russians. His equipment is confiscated, and it's a pity because it would have been really good viewing on the Crimea at that point. Meanwhile, the Americans, from a neutral country, they're not so mad at him. The Russians, you're just an American, but it's cloudy, so he's not able to photograph the eclipse either. Plus, the Russians confiscate his advanced equipment, and he goes back to America with everything taken away from him.
Oof.
And it's not till 1919 again that they're able to test this, and that's where Sir Arthur Eddington gets involved. And he gets some results the data are not exactly so clear, like maybe. It may kind of look like he's got something proving, and he publishes in the end, but there's some uncertainty about that until a few years later when William Campbell goes and takes measurements of yet another eclipse in Australia, and that proves that Eddington was correct. So Eddington ended up proving general relativity. And it turns out that it's really good that it took them until 1919 and that they didn't use the data from 1914 because Einstein had something wrong in his calculations that led him to rethink general relativity and tweak it, something involving the orbit of Mercury and all that. And if the German researcher had been successful, it would have made Einstein look like he was wrong and would have discredited him. So in the end, it worked out.
For you.
Yeah.
Yeah, that's I've not heard that one before. I mean, I knew about the moon being used to qualify general relativity, but I didn't realize that there was that the close call with the data. That is really interesting.
Oh yeah.
Has there been any other sort of British involvement with the moon? And
there's a lot. There's back in the 18th century, you had the Lunar Society of Birmingham,
which is obviously my hometown.
You'd think just hearing the name that it would be people who wanted to go to the moon, but it wasn't that exactly. It was people who utilized the moonlight when it was a full moon so they could have meetings at night and just discuss how to advance humanity. And this included a lot of people who were instrumental in starting the Industrial Revolution. The leaders were Matthew Boulton, who took place at his house. He was an industrialist. And Erasmus Darwin, grandfather of Charles Darwin. They got it going. Erasmus Darwin was a physician who had really an early evolutionary hypothesis that Charles Darwin kind of drew on that a little bit later. They never knew each other because Charles Darwin was born after Erasmus had died. Other people involved were...
wasn't it Wedgwood?
Josiah Wedgwood, yeah, another the chief people. He also was a grandfather of Charles Darwin. He was the maternal grandfather of Darwin. The idea was that he had the famous Wedgwood pottery. In those days, you put your pottery on a wagon with a horse. It's kind of bumpy, and sometimes it would arrive not in the best shape where it's going. So Wedgwood thought, well, what if we dig canals throughout Britain, and then we could put them on barges on the canals, and it'll be a soft travel that way, and we won't break up all our China and all that. Now, that was his motivation. James Watt, he was another one. James Watt, the inventor of steam power. Also, Joseph Priestley, one of the people who discovered oxygen. Fairly important people there. Benjamin Franklin dropped in every now and then when he was living in London right before the American Revolution. And they talked about, just cool things. What will we do? Erasmus Darwin had an idea that we could use the world's navies not to fight with one another, but to drag icebergs from the poles to the equatorial region so we could make the equatorial regions cooler and everyone would be more comfortable. They would just brainstorm things like that.
That is some group of people, has to be said.
Yeah. So that way they would just stay up really late at night, and the idea is use the moon to be able to have light to get home. Although a lot of them probably ended up staying there the whole night anyway, so maybe they didn't need the moon.
So what was next?
Well, the BIS is a big one, the British Interplanetary Society. Amazingly, in 1939, when everybody was going through a crisis, World War II beginning, there were some visionary engineers who had the idea that, well, the way that rocket technology is developing now, maybe we ought to consider if it would be feasible to actually send people into space. They had rocket engines. They weren't very powerful engines. So they had an idea for clustering of engines. So they came up with this design scheme where they had more than 100 engines on each stage. They had about, I think, 5 stages with like 160 clustered rocket engines in their blueprint, and then an upper stage with like 45 clustered engines. There was no technology in those days to control. Controlling clustered engines is something that the Soviets first did during the 1950s with the R-7 rocket of Sergei Korolev developed, and not as many engines like that. But they were just trying to show feasibility, that if we use the right number of engines and the fueling and we use staging and all that, theoretically, we should be able to send people into space. And they came up with a plan to send 3 people for a fortnight and get them back. So that's the BIS, British Interplanetary Society. Carl Sagan used to talk about this plan of BIS, that it was just a feasibility study, just like now we have studies for starships, like we have the 100-year Starship project. Although it turned out that their idea, actually, we achieved that just 3 decades later.
Well, the one thing that I'm interested in, you're an astrobiologist. So, is there what's the evidence say for life on the moon? Has there, over the eons, has there been any chance that life could have taken a grip? And
well, we don't know what's deep underground. You never know that. If there's if there's a way to get energy, then you never know if there could be life. But in terms of the surface, we're very sure now there's no native lunar life. But there have been a few incidents in the past when somebody thought there could have been life. So during the Apollo program, there was a camera lens that was taken by astronauts of Apollo 12, landed on purpose near the Surveyor 3 probe that had been on the moon for more than 2.5 years. And they took a camera lens back to NASA and a sample of Streptococcus. You go back to the 19th century, you got Franz von Griffithson was a physician who turned astronomer, which happened a lot in the history of the moon. It happened with different people with different careers becoming astronomers. Well, he was using a refracting telescope pointing it at the moon. He thought he saw a city. He thought he saw like parallel streets and city blocks and all that. And he came up with a name for the city and a story about the city, about the inhabitants and all that. But other astronomers of his time were not able to confirm his ideas. Pretty analogous to the story of Percival Lowell looking at Mars and thinking that he saw a system of canals all over the place and a civilization there. Same idea.
It's almost a form of pareidolia, isn't it? The sort of power of suggestion in people's minds. It's like even serious scientists are kind of tricked by it.
Yeah. We often see what we want to see.
In fact, you could almost argue we see what we think we're seeing, rather than actually seeing it.
But now there was a practical consideration for looking alike, because when they were sending astronauts to the moon in Project Apollo, they wanted to be sure, however unlikely, that nothing dangerous would be brought back to Earth. And so there was especially for the first human landing in Apollo 11, there was a protocol in place for preventing back contamination. The astronauts, when they came off, they had to be isolated, and they had to wear heavy biohazard suits when they were taken out of the command module after they splashed down in the ocean. But as you get to the next missions, Apollo 12, Apollo 14, they relaxed their requirements. So in all cases, the astronauts wore respirators when they came out of their capsule. But only on the first mission, Apollo 11, did they wear heavy biohazard suits in addition to the respirators. They were put into isolation chamber that was specially designed so it could travel, be put on an aircraft carrier and put inside an aircraft, and taken to a building, to Building 37 at the NASA Johnson Center in Houston, where they stayed for a few weeks till it could be determined that they weren't sick, that they weren't harboring any organism. They were really, so basically there was a protocol for preventing what's called back contamination, to contamination of the Earth, contamination of humanity, in the event that there are not just lunar life forms, but harmful lunar life forms. It was thought to be extremely unlikely. Carl Sagan talked with the astronauts before they left and kind of gave them perspective on that. Just that it's extremely unlikely, but the consequences, in the unlikely event that there is something pathogenic to humanity or pathogenic to Earth's environment, then that makes it high risk. So for that reason, they were very careful. They had this protocol for keeping the astronauts isolated, for keeping the lunar samples isolated, for people that come into contact immediately when they recover the astronauts, namely a recovery engineer and a flight surgeon, had to go into quarantine with the astronauts after returning on Apollo 11, Apollo 12, and Apollo 14. I don't mention Apollo 13 because they never got to the surface of the moon. As a result, they did not have to go through quarantine when they got back to Earth.
Interesting.
So when you get to Apollo 15, you no longer have a concern about back contamination, but they had a quarantine that they had to put into effect the opposite direction. They started quarantining the astronauts before for the moon. And the reason for that was because if you saw the movie Apollo 13, they go through this history a lot. Was that there was a scare of an infection with one of the astronauts who was supposed to be on the Apollo 15 mission, the command module pilot, had never had rubella when he was a child, German measles. And there was another astronaut, Charlie Duke, who had been exposed to rubella when he was near the time of the mission. That they're concerned that he'd be sick just when the other two are on the lunar surface in the event that he was exposed. So it turned out that he wasn't. He didn't get sick, but they had swapped in another command module pilot, and it was like 2 days before the mission actually left. So they actually had to change around the crew so close to the launch. And from that point on, they decided that they're going to do a quarantine of the crews before they left Earth to prevent any incident like that.
So moving forward, we've got people going back to the moon. What's the sort of plan there in terms of keeping people alive? What if we have a moon village, and what kind of resources are people expecting to find on the moon?
Basic questions about will we be able to walk on the moon? Will we be able to, will we pass out? Will astronauts pass out? They know that won't happen, but they don't know a lot about the long-term survival on the moon. The longest Apollo mission was just 3 days on the lunar surface. The last three, Apollo 15, 16, 17, the J missions, they spent 3 days on the surface, but now we're talking about going back for weeks, even months. And we know there were problems that would have been problems had they stayed longer, especially related to the lunar dust it was getting into parts of the spacesuits and eating through because it's very sharp particles, and they don't really have a total solution for that yet. That's a problem. That's got to be fixed. We don't know about the long-term exposure to lunar gravity. We don't know whether the 1/6 gravity is enough to offset some of the problems that we have in weightlessness. Maybe it is, maybe it isn't. Certainly, we turned into a colony where we got families living there and people trying to reproduce. We don't have the answer whether it will be safe to reproduce, get pregnant, and have babies in lunar gravity. In terms of the radiation, probably it'll be safe because we'll be underground anyway. But the low gravity, that's kind of an unknown. It'll have to be years and years of research and laboratory animals.
How the body adapts to gravity, particularly, and I think there's probably the short term risk of radiation as well on your journey there. And
there certainly is. If there's a solar particle event, you're in a lot of trouble. You have to have a shelter near you and be able to get into the shelter. Otherwise, acute radiation sickness is a problem. You're not thinking in terms of, will I get cancer in a decade or two? Will you die right now?
Yeah.
That's been the concern.
In terms of those radiation events, was it really a fact that the Apollo missions were actually reasonably lucky in the fact that there wasn't that kind of event?
Yeah, there were lucky. Yes, there was even the novel by James Michener called Space, where there was an Apollo 18 and there was a solar particle event, and I think an astronaut died or 2 astronauts died.
What's your feelings in terms of when we'll see the next boots on the moon, and then how long after that do you think we will actually see a lunar village of some description?
Oh, the ESA plan is for the 2030s sometimes, but we in the space community, we always have to be skeptical because they always tell us we're doing this by such and such year, and then it ends up, how many decades later. But there will be a lander. Lockheed Martin is working on a lunar lander, so that might be helpful. You do need to land and have a really good, a pretty big lander, and we know it'll happen with private companies, SpaceX and other companies. They have to have landing capability on the moon. And right now, it looks like NASA and the Lockheed lander, maybe they may have more. NASA doesn't really have its lander plan unless it's buying the Lockheed lander, but I guess it would be buying that lander. So once you have that capability, of course, we got different countries landing small packages on the moon now. Israel is about to, it's a private organization within Israel that was launched by SpaceX. Space.il it's called, and it's been in the news recently. Yeah. As long as there's no mishap, it'll be the 4th country to land something on the moon after China. And then India, the Indian Space Research Organization has something going, the Chandrayaan-2 mission that's supposed to land on the moon, and it keeps getting delay after delay after delay. And ISRO, not to be confused with Israel. Yeah. ISRO of India, they're being kind of hush-hush about their launch date, about when will that happen.
Yeah, indeed.
Yeah, it could happen tomorrow, it could happen. We don't know. They're not going to beat Israel there because they, just like the Israeli probe that's taking the scenic route because they don't have a Saturn V, so they have to kind of get into geosynchronous orbit, and they keep making their orbit bigger, and it takes weeks. India will be doing the same kind of thing, so they will not catch up to the Israeli lander. So they'll be 5th.
Thanks very much for taking the time to do the call. And I've learned something about my hometown, which was really good. Thank you very much.
Cool. Yeah, thanks. Nice talking with you. Excellent. Thanks, Matt. Nice talking with you.
The Interplanetary Podcast, putting the ace back into space.
Absolutely need to read that book now.
There's a lot of very intriguing chapters. I can't wait to get my hands on it. Jamie, do you want to hear my space fact?
Do I? I mean, yeah, I do.
Yes, I thought you did. There are 2 gargantuan chimneys at the centre of our galaxy, spewing out X-rays. What are you going to say about that?
Now you have my attention.
So yes,
wow.
Yeah. Well, again, we're back to ESA's, one of ESA's like massive bunch of satellites that it's got out there. The XMM Newton as basically
one of my favourites.
Yeah, well, way back in 2010, the NASA's Fermi Gamma Ray Space Telescope discovered these two giant bubbles, or you could consider them burps, massive
I like that.
burps of material from the black hole at the centre of our Milky Way, Sagittarius A star. All these huge burps of material, one massive lobe going up and one massive lobe going down. But XMM Newton has discovered the sort of chimneys that these come out of, two channels of hot X-ray emitting material streaming outwards from Sagittarius A star. So it's finally linking the immediate surroundings of the black hole to the bubbles themselves. So this is this has been like so much data, so 2 years of data to create the most comprehensive X-ray map ever made. So
you're saying that our galaxy's core is actually, even though it's described as dormant, is actually a lot going on, Matt. It's pretty chaotic.
There's so much going on in the galactic core. And
I love here that in the notes we've got dying stars exploding violently, binary stars whirling around one another, and Sagittarius A itself massive as 4 million suns, chomping on all this stuff and belching out radiation and energetic particles as it does so. I mean, come on.
And that's a quiescent, dormant galaxy black hole, yeah.
What other podcast gives you that as a paragraph?
Oh my God, Jamie! I tell you what, I did see.
Go on.
I did actually watch, Behind the Curve or Beyond the Curve or whatever it's called on Netflix.
Oh God! Did you get further than 10 minutes?
I watched the whole.
That's all I got through.
I watched the whole thing.
Oh, did you shout and get as angry as I did?
No. I found it quite fascinating because the sort of main guy who had the T-shirt, I am something.
I hate him.
Oh no, he's not.
Well, hate's a strong.
No.
Hate's a strong word. I'm just frustrated with his logic.
I don't believe him. I really don't believe that the whole thing's a pantomime. It's for those. He's
just earning money.
There was a few of them that it was clearly a bit of a pantomime. It did finish.
That's like we don't really believe Marcus Allen. Some of the stuff he says.
Well, funnily enough,
he's just doing he's just too famous off the back of it.
Yeah, well, that's exactly it. He'd found his kind of feet with this community. It finishes on a very good note where one of them's doing an experiment and it clearly shows that the Earth is curved, and he goes, "Oh, this is interesting. This is really interesting." And it's so funny when they have these experiments that reveal that, of course, the world is a globe. They just ignore the evidence and try and fudge some other explanation. I was going
to say, did they then say they were wrong?
Well, but no. What they said was things like this gyroscope that was doing exactly what you'd expect it to do. They've said, "Oh yeah, that's being caused by some kind of heaven energy or something." It was ridiculous.
Heaven energy. Wow. Okay.
I think we should talk about a whole bunch of ESA satellites that are coming up. You really want to talk about Cheops, don't you? And I want to talk about.
I really want to do that.
And I really want to talk about Athena and where it all started for us, Jamie. Lisa the Lisa laser. We talked about Lisa Pathfinder. It was on our very first shows, and Lisa itself, long way off, but that is a very exciting space telescope.
Absolutely.
A gravitational wave detector in space. That's gonna be crazy times for astronomy. So, Jamie, shall we let the listeners go?
We're going to release you
from this torment,
this absolute drivel, and we'd like to thank you. I tell you what, Matt. Before we go, if I'm a new listener and I've enjoyed this interesting talk, what can I do?
Pop over to iTunes or wherever you,
yeah.
or wherever you listen to your podcasts. Could be Spotify, could be Google Play.
Should I leave a review?
Could be Stitcher. Yes, please leave a review. It helps other people find us, Jamie. It helps other people
getting
find
in contact?
us.
I mean, surely I can't get in contact with you and
You absolutely
ask you questions.
You really can, Jamie. You can
what?
You can take part in the show. You can even correct us. Like we got corrected on Christina. It's actually Christina Cook is her name.
It's Cook.
It's Cook, not Cock. I was thinking it was Coke because, of course, the Koch brothers are spelt the same, aren't they? So, yes, but it's Cook, apparently, Christina Cook. So thank you very much for that correction.
I can see why someone would want that corrected, so apologies.
Yeah, I think we did very well to get through several podcasts without...
There wasn't one snigger. I tell you what, if it's one thing we're known for, it's our maturity on this podcast.
Absolutely, so Jamie, absolutely.
We did very well.
Yes, make your way over to interplanetary.org.uk. Notes for the show always are there. You can communicate with us there. You can sort of go out to all our kind of social media outposts, those deserts that are extra content from us two buffoons here in England.
So, Matt, I'm going to go and measure my thermal radiation. What are you up to?
I'm going to be editing a podcast to get it out to the Spodcats for tomorrow.
Oh, my Lord. Well, have a good weekend, everyone. And don't forget, above you, below you, out in front of you, somewhere in the distance, there's a spinning asteroid. I don't know where I'm going, Matt.
Oh,
help me out.
Okay, Jamie. I think it's time to go.
Definitely is.
Bye-bye.
See you.
Bye-bye, Spodcats.
Bye.